other page you got. That's just diagrams, right? We didn't go through that.
Yes, that's the notes that we'll do the second part today. So okay, so like I said, this is the end of the states of matter and phase changes. So we basically got through. We were talking yesterday about the the 6 different phase changes. 3 of them are exothermic and 3 of them are endothermic, right? And remember, we were talking about trying to look at the phase changes and think of them in terms of gaining or losing energy, not necessarily as hot or cold, right? Okay, so the state of a substance at room temperature depends on the strength of the attraction between the particles, between the molecules. So molecules have what are called intermolecular forces, forces of attraction between neighboring or molecules that are close to each other. Attractive forces means it's kind of pulling them together. All right. And what happens in a phase change is essentially the molecules either get closer together or further apart. Remember, that's the only difference. It's not a chemical change. Just physically, the molecules get further apart or closer together. That's what causes it to go from a solid to liquid to a gas, or gas to liquid to solid. Make sense? Or plasma too, but we're not really doing much with that. Okay, let's flip it. This is an old copy, so I updated yours with this thing in it. But so this little diagram here, it just lists the states of matter. And basically, what I've done is kind of given you a little diagram deal so you can look at this and understand the relationships between the different states of matter and what is happening to the intermolecular forces, the energy or heat, and the particle movement. Okay, so for example, as you go up this list, the intermolecular forces, the forces between the molecules, get weaker. Okay, because you're adding more energy and more heat. So think of molecules and intermolecular forces kind of like magnets. So if you got 2 magnets and they're really close together, that's when the attraction, the strength of the magnetic pull is the strongest, right? As you move them further apart, what happens to that attraction? It gets weaker. Yeah, it gets weaker, right? Like it might be hard to pull them apart at first, but once you get them out here, it's not really hard to keep them that way, right? So that's like molecules too. The closer together they are, the stronger those attractive forces are, and the further apart they are, the weaker those intermolecular forces get. Okay. Just keep an eye. Whenever you can just check it. Okay. All right. And then energy and heat. We've talked a lot about this, right? As we're going up this list, in order to move up this list, we're adding more energy or heat. And in order to go down that list, we would take it away, right? And then the same thing with the particle movement. As we move up this list, the particles are moving faster and get more spread out. As we go down this list, they get slower and closer together. So basically, this is kind of all of that concept together in one little diagram. So for example, if I asked you, okay, so we talked about dry ice, right? Carbon dioxide going from a solid to a gas. So if I asked you guys, if you were to compare dry ice, like solid carbon dioxide, to gas carbon dioxide, which one has more energy?
The gas.
The gas does, right? Solid is here, gas is here. Energy, gas has more than solid does. So this is just something that just to kind of put that all together, and you can use it to compare these 3 things. So you have liquid wax in one container and solid wax in another container. Katie, liquid gas in one container, or liquid wax in one container, solid wax in another. which one has stronger intermolecular forces?
Solid.
Yeah, good, right? Right, we're here, and then we're comparing liquid and solid, so solid is below, means it's stronger. Does that make sense? Everybody kind of get how we're looking at that? Okay, any questions?